Good morning.
Good morning.
All right, well, let's see who's here. Uh, is Jordan there in Holbrook?
No, she's gone today.
Okay. And how about Caden in Joseph City?
I don't know. I haven't seen him yet.
Okay, thanks. All right. Sorry, my attendance page is not loading up. Let's see. Okay. All right, so Jordan is not here. Caden is not here. How about in Winslow?
Everybody's here in Winslow.
Wonderful. Thank you. Okay. All right, so let's okay, so I had asked you to come up with a sequence. I'm gonna teach you a little bit about recursive sequences first, and then if you have a sequence that you can stump the class, we'll probably do that in about 10 minutes. Okay. Um, let's see, other things that you might want to get out your calendar and just so you know that right now, um, so the last 2 days, the last two Talon days are May 8th and 9th. And so those would be the last days that we could possibly have the final. And so that's kind of what I'm scheduling right now is May 8th and 9th. And then I'm hoping that we would have at least a day or two of review so that you could ask questions or maybe, I see Caden. Um, and then we might, maybe even have like a Moodle day or something that last week or whatever in case you need to get caught up on a quiz or a test or something like that. So right now you can kind of pencil in the final being the 8th and the 9th during class time. Okay. And then as we get a little closer to that, then we'll kind of confirm that. But any questions on that? Any concerns? Okay. So anyway, it'll be kind of similar to the last one, the last final. So, so today we're going to, again, we're going to go back to 11.1. And so we were right at this slide on the recursive sequences, which is at the bottom of the first column on page 1 of your guided notes. Okay, so any questions, comments before we get started?
When are you gonna upload the videos from last week?
Oh, I got another email. They're really having troubles with the VBrick, and so nothing has been I think I got up to 2 weeks ago, and then it's so anyway. I got another email this morning saying that they're still working on it. So I'm hoping that Anyway, I'll check again this afternoon, and if I'm able to upload them, I'll let you know tomorrow. Okay.
Okay, and then, so if you can't upload them, then what do we do about the attendance?
If I can't upload them, then what?
What do we do about our attendance?
Oh, well, I mean, let's say that they're lost in cyberspace forever, then I'll probably, if you were gone for a school absence, I'll go back and I'll give you full credit on that. Okay.
Okay.
Right. Okay. So let's, but I really want them to, because there's some people that need that material. So anyway, I'll try to let you know. I'm hoping that it's going to get fixed. And the guy that's working on it is really good. So I suspect that it'll be done. So, okay. Well, today we're going to start off on, we were talking about sequences, and I want to define what's called a recursive sequence. All right. So to define a sequence recursively, you need to be given one or more of the first terms. And then all of the other terms of the sequence are defined using previous terms. So if I said take the last term and double it, see, then that would be using the previous term to get the next term, or something like that. Okay? All right, so now, the most famous of all the recursive sequences are what's called the Fibonacci sequence. So, have any of you even ever heard of that, the Fibonacci sequence? Raise your hand if you've heard of it. No? Oh, yeah? Okay. So, like I said, this one is one of all of the sequences, this is one of the few that actually has a name. Okay? And it's a recursive sequence. So, the way the Fibonacci sequence works, it's pretty simple. The first two terms are 1. And then from thereafter, the next term is the sum of the previous two. So we say that a sub 0 is 1, a sub 1 is 1, and then a sub k is equal to a sub k minus 2 and a sub k minus 1. So that means the previous sequence, the previous term, and then the one before that. So the first term is 0 and the second term is 0. So like I said. So then the next term, if we add those two, we get 1 plus 1 is 2. And then to get the next term, you would add 1 and 2 together and get 3. And then the next term, we would add 2 and 3 together and get 5. And then we add those two together and get 8. So what would be the next term in the Fibonacci sequence?
13.
13. Okay. So now this sequence is pretty amazing because, like, let's say, back in the day, architects would arrange buildings so that the size of the rooms were in the form of a Fibonacci sequence. So they would have, like small closets that would have like an area of 1. And then this might be a small bedroom that'd have an area of 2. And then this one would be 3 and 5. And then like the courtyard or the dining hall would have an area of 8. So, and of course it would all be proportional. So whatever size this is, this would be 8 times that. And so they would lay out buildings to form this Fibonacci sequence. And there's actually archaeological evidence to show that this is actually an artifact from Peru. And it shows, and they're not quite sure what this was used for, but it actually shows evidence of their knowledge of the Fibonacci sequence. This might be, if you were to take those rooms and draw a spiral that would intersect, go from corner to corner, in all the rooms of the Fibonacci architecture, you find what's called the Fibonacci spiral. And so the Fibonacci spiral occurs like in nature, in like conch shells and different seashells that have this Fibonacci sequence as part of it. This is kind of fascinating to me that as you take different measurements of the human face, there's a certain order to them, and the closer that the symmetry of your face follows the Fibonacci sequence, that they've shown that regardless of culture or race, that people whose and I'm not sure what the order is on what the different what they're measuring, but it's like the closer the face follows the Fibonacci sequence, the more that people perceive you as being beautiful or handsome. Anyway, to me that's kind of fascinating. And again, anywhere in the world, there's a Fibonacci sequence in music, and I used to be able to play it, and that somehow the link got broken. The Fibonacci sequence can be found in nature, the spirals of a sunflower, or the spirals of the stars in the galaxy. Now that just blows me away, but the Fibonacci sequence, even among astronomers, they call it God's fingerprint, is because you find this sequence of numbers just in places all over the universe. And so it's kind of fascinating. This is just a chimney at a plant in Turkey where they've just put the Fibonacci sequence. Somebody was a big fan, I guess. Anyway, but the idea of the Fibonacci sequence being found out in the universe, in different galaxies, that's been sort of a new discovery. All right, so again, the Fibonacci sequence is an example of a recursive sequence. Okay, but anytime that you define a sequence based on the previous number, that's called recursive. So for practice 1C, it says write the first 5 terms of the sequence defined recursively. So it says a sub 1 is 6. So I've given you the first one. Now the way that you interpret this is a sub k plus 1. So the next number is the a sub k, the previous number, plus 1. All right? So see if you can do that. Give me the first 5 terms. All right, so Shannon, what do you have?
I didn't get it.
Okay, so if the first number is 6 and the next one is that number plus 1, then what would be the next number?
7.
7. And then what would be the next one after that?
8.
8. And then what?
9.
And then what?
10.
Okay? So it's just the previous number plus 1. So it's kind of how we learn to count. All right? So recursive just means you use the previous term to get the next one. So if a sub 1 is 3 and a sub n plus 1, so that means the next term is the previous term plus 5, then what would the second term be?
8.
8. Okay. All right. If the first term is 2 and a sub n is 3 times the previous term plus 1, then what would the next term be?
7.
7. Now, notice how I've got the rule written 2 different ways, but they actually mean the same thing. So I could say a sub n is 3 times a sub n minus 1, so that's the term before plus 1. Or I could say the next term is 3 times the previous term plus 1. So there's not one way that you can write the rule. There's several ways that make it possible.
Mr. Strong, can you go back to the practice?
Sure. All right, you got it? Okay.
Yes, thank you.
You bet. Okay, so simply listing the first few terms of a sequence is not enough. So the nth term must be given, or in other words, like the formula or the pattern, where I say a sub n equals blah, blah, blah. Okay, that's how you get the pattern. So that, because if I tell you that, the pattern is 1, 2, 3, what's the next number? Well, you might say 4, and that would be correct. Or if you said 5, maybe the pattern is all of the non-composite numbers. 1, 2, 3, 5, 7, 11, like that. So that's why we need a rule to the nth term, the formula, to help us know specifically what comes next. That's kind of the better way to go. So this says to write an expression for the apparent n term, for a sub n. So for 1, 3, 5, 7. So we're going to try to write the formula for that. Okay. Now, this is kind of how you do it. Do you see that there's a common difference between these numbers? Okay. What is it?
-2 or +2.
+2. So it goes up by 2. So you start off with a sub n equals 2n. And then what you're going to do is you're going to add or subtract a number to make it fit the pattern. See, when n is 1, 2 times 1 would be 2. But the first number is not 2, it's 1. So that means we're then going to subtract 1 from the number. So when n is 1, we get 2 minus 1, which is 1. When n is 2, we get 2 times 2 is 4 minus 1, which is 3. When n is 3, 2 times 3 is 6 minus 1 is 5. Okay? So whatever the difference is between the two, that's the number that goes in front of the n. And then you add or subtract a number to make it fit. Okay, and so
Why can't you just do n plus 2?
Well, so when n is 1, n plus 2 is 3. Not that we want the first term to be 1. See, a sub n, or and really you have to do a little bit of trial and error. But see, when you start off the first term, when n is 1, it would be 3, not 1. And the second term, when n is 2, 2 plus 2 is 4, see, that's not up there either. So it doesn't work. But that's okay. You have to do a little trial and error. So when you get the common difference, it goes up by 2 each time. It's not from adding 2, because that's just adding 2 one time. What makes it go up by 2 each time is putting that number in front of the n. And so then as n goes up, it's going to go up 2 more every time. Okay? All right, so great question. Any other? All right, so let's have you try practice 1D. All right, Brooke, when you've got it.
A sub n equals 4n minus 3.
4n. Oops. 4n minus 3. Great job. So a sub n equals 4n minus 3. So that means the nth term. So when n is 1, you get 4 times 1, which is 4, minus 3 is 1. So that checks. So when n is 2, the second term, 4 times 2, 8 minus 3 is 5. And so once you come up with, what you think the answer is, make sure that you plug in and check it, see if it's working. So good job.
Is the solution always like that when you're adding, where it's like one less than?
Well, no, it's okay. So the common difference is going to be the number in front of the n, and then you'll have plus or minus something that will make it work. Okay, so you'll add or subtract a number. You just have to see what works there. Now, whenever you say, "Is it always?" Okay, in math, it's never always, because there's always see not all these sequences are what we call arithmetic, where they go up by the same amount each time. Not all sequences do that. Okay, so I'm just kind of showing you the rules for these. Okay. All right. All right. So now let's look at some of the patterns. Okay. Okay, so again, let me just kind of give you some examples of what are not good patterns. Okay, some of you might know this one. Anybody know what would go next on that one?
Is it a D?
It's a D. So what's the pattern?
It's the days of the week in Spanish.
It's the days of the week in Spanish. So see, that pattern's not fair, because if you don't speak Spanish, you can't get that. All right. So we don't want that. I mean, I speak Spanish. Or like this is kind of this one's pretty tough. But this is actually the first line of the words in Twinkle Twinkle Little Star. So twinkle twinkle little star, how I wonder. And while that's kind of specific, this would be legitimate. This is a definite pattern that we all know the words to Twinkle Twinkle Little Star, I hope. But see, this one is unfair. Anybody know what this one is? All right, let me give you the hint. This would be the numbers in Navajo. So, anybody know what the last two would be?
A T.
T and another T? Yep. Okay. And see, I would have to take your word for it, except that, somebody's done that one before. But so that's kind of unfair because that's not in our common database, so to speak. Okay, so having said that, let's see if, okay, this one is pretty easy because by the time you get to trig, everybody ought to know this pattern. What are the last two?
AS.
AS, because it's the order of operations. Okay. Let's see. And while this one is not as good, I don't think, not as clear. Again, this is one that you ought to know. Actually, this is the class you're in right here. So what comes next?
C?
C. So this is high school math classes. Okay. All right. And we got that one?
It's IV.
V. Okay. So the colors on the rainbow. Okay. So unfortunately, when you get a good pattern, sometimes it's easy to get. So, all right. So let's see if if somebody has one that they'd like to do, and I'll write it up, and we'll see if you can stump me or stump the class. Okay. All right. So Ellie, I know you've got one. Let's start with you.
So it's BP, and then AIW,
Yes, thank you.
and then AM, and then the and sign W, and then the ... and then AEG.
Okay. Actually, let's make this a blank right here, because this is the blank we want to fill in. All right. So, anybody know what's missing up there? And actually, let's make it a little harder. It really should, we'll just make it AE. Because it's just one word. Right? Okay. Yeah, Ellie didn't stump me on this one, but I thought maybe we could stump you guys. Anybody have a guess? All right, Ellie, you want to give them a hint without giving it away?
Think of like Marvel.
Okay, so Marvel. That's the hint. Whoop. Okay, now anybody?
Is it CM?
It is CM, right, Ellie?
Yeah.
And so, explain the pattern for us.
So it's like the order of all the movies, Avenger movies, and well,
Yeah.
Marvel movies. In
So, Black Panther, Avengers Infinity War, Ant-Man and Wasp, Captain Marvel, Avengers Endgame. So this is Marvel since 2018. Okay? All right, that was a good one. I like that one. All right, anybody else have one? All right, how about this one? All right, you need the clue? So the clue is like the last one, think of movies. No? Okay. Next clue would be think Star Wars.
No.
So what is it?
F-A.
He already has a thing.
R-J.
Yeah, ROTJ, RJ. Return of the Jedi is the missing Star Wars movie. Okay, very good. All right, let's try, let's see. I forgot what this one is. Oh. Okay, so the hint here is a song that we sing at Christmas time.
That's R.
R. And what does R stand for?
Rudolph.
Rudolph. So this is Santa's reindeer. Good. Good job. Okay. Oh, this one is hard. This one is hard. As a matter of fact, the guy that did this one was sure no one was going to get it. And I got it, and it really disappointed him. But this was pretty hard. If I hadn't got an A in my high school government class, I would have never got this one. So this is from government.
So it's like president, vice president, secretary of
Yeah, so what is that? What is this we're doing here?
You're going down the line, right?
Yeah, it's the line of succession. So
Yeah.
like if the president dies, the vice president takes over. If the president and the vice president dies, the next is the Speaker of the House. And then the President of the Senate, Secretary of State, Secretary of Defense. And anybody know who's next? I just actually guessed and got it right.
Is it AG?
AG, yes, the Attorney General. Okay, awesome. Most impressive. Okay. All right, this one, let's see. I forgot what this is. Oh, yeah. Okay. Music lovers. If you're into music, you should know this one.
So it's F and T.
Yeah, because it's... so what is the pattern?
Do, re, mi, fa, sol, la, ti, do.
Good, good, good. Going into that. All right. We'll do one more. Now, I'm not sure why the person that did this did it with the point in the middle, but each letter represents a different word, and so that's just how they wanted to do it. So like S.S means there's two S words. Let's see, what hint can I give you without giving this one away? If you don't get this, that doesn't mean you're dumb, bold door. So can anybody tell me what's missing? Okay, it's the Harry Potter movies. Okay, so what's the sixth movie?
No.
What is it? What's the sixth movie? Or book?
Half-Blood Prince.
Half-Blood Prince. And then the last one is Deathly Hallows. Okay. So anyway, they're just kind of some fun little patterns here. So, anybody else have one before we move on?
We have one.
Okay. All right.
Okay.
Lay it on us.
Okay. It's AD,
AD,
HG,
HG,
HP,
HP,
LL,
LL,
NL,
ML,
SS,
SS,
blank blank.
blank, and then another blank? Or two
Yes.
blanks in the same? Like that?
Yeah.
Okay.
Mr. Strong, and it's with an N
Not an
as a nickel, not M as a mouse.
Oh, like NL?
Yes.
Okay. NL. So are these names? The people?
Yeah. Yeah.
Let's see, are they real people? Or fictional people?
Fictional.
Fictional. Fictional people. So are they?
It's Harry Potter names, but we can't figure out what the last
Is it
two are.
is it Harry Potter names?
Yeah, I think.
Is it?
Yeah.
it is.
Okay, so Harry Potter. Who are the other ones? You guys in Joseph City, help me out. Who are these other
One
ones?
of them's got to be RW, right?
So we have
So you have what?
Yeah.
Yeah, so RW, so Ron Weasley, I guess. Neville Longbottom? Yes?
Yeah.
What?
So are these
LV?
like the member of his little group? No?
No. The last one, like, you should get it.
Is it so we've got this is Hermione Granger. I don't know what the pattern is though. So I have no idea. Tell us what's the pattern and who's the last person.
Well, it's just like the character's name. So it's Albus Dumbledore, Hermione Granger, Harry Potter, Luna
Okay, but
Lovegood.
that's not a sequence.
Oh yeah, but like, can it be like the character's name? Like I put it
Yeah,
up.
but the order. Remember, like last time I did like the Ninja Turtles. See, that's not a good sequence because there's no order to it. Whereas,
Oh,
like when we were talking about the orders of the book or the movies, the order is important. See, if you just do like random, there's no way we could figure out the order because there's no order to this. So I mean, if you mixed up the things, if you mixed up the initials and it didn't matter, then that means that it's not a sequence. Okay.
I have a sequence, Mr. Strong.
What?
I have a sequence.
All right, let's hear it.
Alright. H S blank C B M together. H blank and RB.
MRB?
No, RB, just RB.
RB. Wow. So we've got H's twice. So are these fictional characters?
No, not really. They're
No,
not exactly characters.
they're not characters. So do these represent people?
No.
He said
No.
think of a commercial.
What?
A commercial? Think of a commercial.
The commercial. Wow. A commercial. That's the problem. I don't watch commercials. All right. Anybody else help me out? All right. Go ahead and either give us a hint or give us the answer.
A cereal commercial.
Cereal.
How
Cereal.
about them?
Let's see. Is this like Lucky Charms or something?
Yeah.
Yes. So, hearts.
Hearts, stars, and horseshoes, clovers and balloons,
Hourglass moons.
hourglass of rainbows, and tasty red.
Okay, see, that's kind of unfair. That's an unfair one because, see, when I was a kid, they only had like 4 different kinds of Lucky Charms. So that one's tough. But I'll give it to you. That's a good one. So, all right. Well, let's go back. We got just a few minutes left.
Wait, we got one more.
All right, one more. Okay.
Okay, so the first one's blank.
Blank. Oh man.
6, comma, 7, 5, 3, blank, and then 9 is the last one.
Wow.
Oh,
8
it's
and
like a
0.
song.
675-309. There we go. So 8675309. All right. Thanks. The song. Whoever said that was the deciding information there. So all right. Thank you. That was good. All right. Well, let's go on. Maybe you can come up with some more. All right. Let's see. Okay. No, we're just going to go to the summation part. So we're not doing this. Maybe. Okay, here we go. Okay, so next, summation. Okay, so the sum of the first n terms can be represented by this, looks like an E, but it's actually the Greek S. And it's called the summation or the sigma. So it's written as like this little E thing. Okay. Now, I is called the index of summation. So it'll say I will go from 1 to n. N is the upper limit. So what the number up here is the upper limit of summation. And then whatever that it starts is called the lower limit of summation. Now, so this is kind of a way to write something very compactly. Okay. Have any of you done any computer coding at all? Well, in computer, when you're writing a program, if you want it to go through a loop so many times, you use an idea like this. Say for x equals 1 to 10. And then that will circle through the computer code 10 times. Or however many times you want it to. Okay. So, now it's interesting that in both of these symbols actually mean a sum. So this is a summation symbol that we use now. In calculus, this integral symbol also means sum. But it's kind of funny to me, like in TV shows and movies, whenever they want to show like some fancy math going on, or like here's this like scientist or whatever, they will always show these symbols because the average person thinks that they're all complicated, but it's just showing a sum. So if we want to say do the sum of 3i and I goes from 1 to 5, then first you plug in 1 for I. So 3 times 1, then 2, 3 times 2, and then 3, 3 times 3, and then 4, 3 times 4, and then 5, 3 times 5. Then what you do is, then the summation sign means then you add those up. So then you work it out, and you add it up, and you'll get a specific number. And so the answer then is 45. And so the summation is the answer, the sum of all of those. Okay? All right. So see if you can do practice 2A at the bottom of the page there. All right, so Rex, when you got it.
44.
44 is correct. Good job. Any questions on that? All right. Okay, now there's some properties of the sigma notation that basically, let me kind of decode these so that you understand. If you're just adding up a constant, if C is a constant, and you're looping it through n times, well, then your answer is just going to be C times n. Because like, let's say this is a 5, and I goes from 1 to 4. Then you're just adding up 5 4 times. So the answer is going to be 5 times 4. All right, number 2, if you have a sum where it's a constant times a formula, you can pull the constant in front and do the summation and then multiply by the constant at the very end. So you don't have to have it in each term. You can just multiply it through once. All right, then if you have the summation of A plus B, you can sum up the two terms separately. So you can sum up all the first terms, sum up all the second terms, and then add once at the very end. And then if you have a minus, you can do the same thing. Add up all of the first terms, add up all the second terms, and then subtract. Okay? Anybody need more time on that?
Yes, please.
Yes.
Okay. All right. Okay, so now these are 4 summation formulas that they have in the book, and I want you to know that they're there. But really, the only one that we're going to really talk about in length is number 2. So in class tomorrow, that's the one that we're going to really use. But, just know that they're all here. So like if I wanted a short, so the sum of the first 5 cube numbers, I could use this equation 4 here. So then I could say, well, it's 5 squared plus 6 squared divided by